really excited to hear about your work.
All right. So the title is Towards Developing Machines that Understand Multimodal Medical Records, but it's going to be mostly about question answering. So I'm going to lay the groundwork of why I'm interested in question answering in general, and then talk about a few of the projects that we are doing in our lab. Mostly is, if you look at it, it's just QA. Like fact KJ is fact checking, but that also is another form of QA. So it's mostly QA, and then a little bit of recent, everybody talks about LLM. We do LLM as well. So a little bit of that, and then some of the limitations that I think is limitations of QA, basically. So let's dive in. So the reason that I'm interested in QA is because I want to use it as a form of evaluation. So to ask the question, how do we know if something understands something? Like an entity could be people, like humans, or dogs, or cats, or even like mice, or functions like logistic regression, like machines. So how do we know if an entity understands anything? So if we stick to ML, because I'm a machine learning guy, so if we stick to ML, logistic regression, we have a pretty good idea how to dissect it. Basically, we study its coefficient. We look at a coefficient. If it's positive, it's positively correlated. If it's negative, it's negatively correlated. And then you have your own domain knowledge, and then you compare it with it, and then see if you're satisfied. So that's one way to do it. Confidence is a little bit trickier than logistic regression, but we still can't visualize kernels. We can use heat maps like BradCam. Still, it gives a pretty good idea what it's doing. RNNs and transformers, I would say now it's becoming a little bit more like gray area, because we usually study the attention patterns, or maybe we do perturbation studies, but I don't think that's like good enough. But attention patterns, still, it's an indirect way, and it's kind of episodic. It's like one sample at a time, and you put in a sample, you study its attention pattern, and see if it satisfies you, and then you move on. I think that's not like really good enough. So if it comes to humans, which is way, way more complex than logistic regression or transformers, what is the way? How do we know that if humans understand anything, like medicine or law or driver's license, like driving skills? Like, how do we know it? How do we evaluate it? So we can't do this. We can't. I mean, we could do this with really like simple animals, like worms. We can dissect their neural nets and then see if it actually like connected, how it functions, and how it fires up. We can do that with very simple animals, but with humans, we can't dissect brains to see if their neural connections actually encode knowledge. Like nobody can. We don't have technology, and even if we did, nobody will allow their brains to be dissected to get evaluated. So I think there are mainly three ways to evaluate how humans understand something. So we ask questions, about certain topics, which would be kind of like amount to written exam, or we let them describe knowledge, like write reports, or like myself, I'm doing like give a talk or thesis, reports, essays. And I think the strongest form is put them in a controlled experiment, which is to like having them practice something, like drive a car to see if you can drive a car, or treat a patient to see if you can be a doctor, something like that. So yeah, put them in a control experiment. So all these three modes of evaluation, I think they're like ubiquitous in our daily lives. College entrance exam is an exam. Driver's license exam is an exam. Live medical license is an exam. Bar is an exam. So basically, we give out licenses to qualified individuals after they pass their exams. So I think that is probably the only way to evaluate whether humans understand something. So if we talk about LLMs then, which is just very big transformers, what should we do with it? Like, because LLMs, where they sit between very simple function, which is logistic regression, and very complex, which is a human brain, logistic regressions, we rarely go beyond 10K params. 10K params mean 10K features, and people rarely do that for linear models. Humans have, I read it up on Wikipedia, humans neural connections, I read that there are 100 trillion neural connections in human brains, so that's roughly 100 trillion parameters. GPT-4, based on the leaked information, 1.7 trillion parameters. So based on the number of parameters, GPT-4 sits way closer to human brains than its ancestor, which is logistic regression. So maybe, just being a bit provocative, maybe we should forget about all these, like studying its coefficients, params, or trying to visualize or trying to study attention pattern. We just maybe we just forget about all of that, and then just apply the same principle as we do to humans. Just have it take exams, and or let it write reports, or maybe put it in the controlled experiments. And if it passes, then we just say, okay, now it understands without actually dissecting its, neural connections or parameter values. So that's my take. And I believe this will actually accelerate, like larger models will come in like 2 years, 5 years, and it'll certainly pass the number of, like in terms of number of parameters, certainly will pass 100 trillion. So then what are we doing? Like, are we still going to try to do like Shapley value analysis? So that's that was my thinking recently. I had as I think about this progress or this trend, more clear that there's nothing we can do when it comes to XAI or trying to interpret or trying to see understand the model itself, because we don't even understand our brains. So testing AI for healthcare. So I'm a healthcare guy, and actually I'm more specifically I'm an EHR guy. So how do we know if AI understands EHR? That was my recent question back in 2020, 2021. So if we want to see if AI understands EHR, then we have to create a very rigorous exam, just like college entrance exam, just like medical license exam. We need to create a very, very rigorous exam for EHR, so that if a machine passes it, then we can safely say that, okay, it understands EHR. So that was my thinking. So I'm not going to go through what EHRs. Everybody here already is, they know better than I do. And I'm assuming that everybody knows Mimic 3 and Mimic 4, so I'm going to pass that in. So, yep, question answering for EHR is a promising method to evaluate AI's understanding of EHR. That's my take. And already, if you read all these LLM papers these days, they are being tested on a lot of different suite of exams or benchmarks. Like she has said, like math exam or a common sense exam, or like logical inference deduction exam. Like it's all exams, and they report their numbers like, oh, okay, my LLM is outperforming their LLM in this test and this test by some score. So it's basically what we're doing already. And I think it can be a necessary test, like, EHR test for AIs. I think it can be a necessary test that you have to pass before you go to somewhere else, but it's certainly not a sufficient test. And it's relatively safer compared to control experiment. Control experiment meaning that you deploy AI and then actually let it make decisions for you. That's very, you have to run a clinical trial for that. Compared to that, taking exams is way easier, way cheaper, way less labor intensive. So that's their, in terms of evaluation, that's their pros. And aside from that, just purely coming from the machine learning perspective, outside machine learning perspective, it has some useful application, because EHR is a great source of a lot of facts. You can ask like patient-centered questions, clinical statistics questions, administrative info questions. So if there is an AI that can handle all these questions reliably, then you can use it for a lot of good purposes, and it can help, like lessen the burden of a lot of medical experts in hospitals, such as physicians, nurses, admin staff, researchers, even like policymakers from the government, and also patients. So hopefully we can achieve two goals at the same time, evaluate AI's performance and also make useful applications. So that's why I'm interested in QA. And the problem is that there isn't a lot of like great reliable QA for EHR out there yet. I mean, it's coming around. Like a lot of people are actually coming around. They are paying attention to this topic, I believe. But it is not. It's compared to like VQAs or like Squad. Like that was way back in the past. Like compared to that, in the general domain, we don't have a lot of great resources for reliable QA for EHR. So I think there are maybe 3 reasons. Not enough open source EHR, but so here I'm giving a big shout out to Mimic and EICU, all the open source projects from MIT. And also, if you're in a general domain NLP, guy, you can build your own question, because you're you have a common sense, you have a good general domain knowledge. So you can build your own like common sense QA. But if you want to go for EHR QA, you need to have a very specific domain knowledge to build a rigorous EHR QA questions. You have to be like a doctor or a nurse to actually come up with a great questions. So that's another blocker. And also we need to, this is a more technical side, but need to embrace multimodal nature of EHR. So there is a couple of multimodal question answering datasets out there in general domain, but not as diverse as what is required in EHR. We have like EKGs, we have clinical text, we have tables, we have images, we have a lot of stuff. So if we want to test an AI that can, if it can understand EHR, then we need to incorporate all the modalities at the same time. So someday we'll get there. So I'm not the first guy to do this. There was a initial effort by Kirk Roberts and Dr. Dina Demner-Fushman. I think she was back in NIH or NLM back in 2015 when she did it. So that was the very first beginning, kind of a question answering data set for EHR, but it wasn't based on open source EHR. And it was just kind of more like a linguistic study rather than trying to evaluate AI's performance on EHR. So, but it was there in the beginning. A bit more like large scale, the first attempt at building a large scale EHR QA was done by, I forgot the name. I forgot the name of the professor, and it's from Virginia Tech. So the first author was Ping Wang, and I forgot the name of the professor. So it comes from Virginia Tech in WWO 2020. So it is the first QA dataset constructed based on Mimic3. So it had a lot of, it got some attention, I think, and certainly I paid a lot of attention to it. And it was based on table-based approach. So it's text to SQL. So if you ask a question that can be answered by a table, information inside the table, then you can simply just convert question into an SQL and you're done. So it's very much like semantic parsing or text to SQL research that a lot of people are doing in the general domain using like Spider or like, those kind of data set. So so it is the first attempt, and we actually try to, increase the performance on this data set with our own like methods. And sooner than later, actually, much sooner than expected, we actually hit like saturated performance. Like 93.4 was I think we got this performance 2 years ago. And this was already in the ceiling because the remaining 7% is unanswerable because it's ambiguous. There's typo. The question was built by grad students, not the doctors or nurses. It was built by like several students inside the Virginia Tech lab. So it wasn't like very rigorously tested. So the 7%, you can't answer it. So 93.4 is pretty much like the perfect score. So the reason that we got the perfect score so fast is because the question is synthetic and it was imagined by grad students. Because if you read this question, this is an actual sample that we got from the Mimic SQL, the data set. It says it calculates the maximum age of patients with yada like more. So basically, this is a made-up question. I don't think nurses or doctors will actually ask this question in the real world, but it is certainly an answerable question. This is understandable question, and you can convert this into a SQL, so it is answerable. So it is usable. It is useful in terms of evaluating whether AI understands EHR, but it's not real. So that's probably why we got such a almost perfect scores in so soon. So I thought after this project, we thought that we need more realistic complex QA for EHR. So questions must reflect real world needs. Questions must be complex enough that so we can test AI rigorously, and it should include unanswerable questions so that we know which ones are unanswerable, which one not. And then if AI knows something is unanswerable, it will not answer the question. It will avoid the question. So that comes to reliability. So we try to nail all these at the same time with the first project called EHRSQL. So that's presented last year in Europe, and it was the very first QA dataset building project in our lab. And I say a lot of firsts here, but forgive me because I was using this for promotional purposes in front of government officials, basically, who gave me the money to do this. So I had to. Yeah. So, but technically they're true. Technically they're true. So what we did is we actually ran a survey on 222 medical staff in Gyeongsang University Hospital, which is a local hospital in Daejeon, which is a big city in Korea. So we actually gave them like coffee coupons and donut coupons to answer the questions. And then we asked them what if you had an AI speaker on your desktop and you could ask it questions for your daily routine jobs, what kind of questions would you ask? Like 10 questions from each person. So we got about 2,000 questions. And then my students put a lot of painstaking hours to go through all of them and then categorize them and then templatize them and refine them. So we had a lot of question diversity, and we realized a lot of questions had time sensitive questions. They had a lot of time filters, like last year or yesterday, within an hour. last visit, this admission, like that kind of expressions were like prominent everywhere. So we also had this try to incorporate the time-sensitive questions as well, and also unanswerable questions. A lot of nurses and a lot of doctors actually ask a lot of unanswerable questions, even if we ask them not to. Like you can only ask questions that is answerable by EHR, but they would ask like side effects for certain drugs, but that is not in the EHR. So those are all were all thrown into unanswerable questions. So basically, after that, students for each template, each SQL template, they built a SQL query for Mimic and EICU at the same time. So that was like, it took a long time. This was like an 1.5 year project. It took a long time, and they suffered. They did suffer. So basically, we made a lot of questions in diverse objectives and diverse time expressions and unanswerable questions. And the performance was that using T5 from Google, performance was pretty okay in terms of only answerable questions. Like if you only look at the answerable questions, then it's almost reaching like 88.4 execution accuracy. So out of 10 questions, like 9 of them will be answered correctly. 1 of them will be answered incorrectly. But the problem is that for unanswerable questions, if you ask like 10 unanswerable questions, about 1.5 times it'll try to answer it, even if it's unanswerable. There's no answer for it. Like reservation queries, there's no reservation related information in the Mimic or EICU, but we just put them in as an unanswerable question, and the model, the T5, will try to answer it with some made up SQL. So there was certain unreliability there. So that was a very first effort. And then after that, so after this, obviously we wanted to expand it in a multimodal setting. So that's where EHR XQA comes in, which was recently accepted in 2023 in Europe. So this is trying to build on top of this by incorporating X-rays. So thankfully, Mimic 4 has structured EHR, which is a table, and they have something called Mimic CXR, which is a chest X-ray images and reports. It's a data set that has these pairs. And thankfully, you can link each image to a subject of the patient in Mimic 4. So you can have like a time series of all the events. It also has X-rays from time to time. So you can build multimodal question answering data set on top of this. And also there was another thing called chest imaginal. I think this was presented in 2021 Europe by people from Harvard and IBM, I think. So chest imaginum is a annotated radiology report from Mimic CXR. So this is a snippet from chest imaginum, which is there is a patient ID, and then there's all the things wrong with this patient. So the body part has something like this. It's a little bit like the text is really small, but it's like right apical zone has pneumothorax, right chest wall has subcutaneous something, and cardiac silhouette, it seems like enlarged. So it's basically like a knowledge graph. So it has this kind of knowledge graph for all the images. So if you have this, then if you mix this with Mimic 4, you can build a multimodal question answering data set, such as this. Like, has some patient received the cardiac catheterization procedure in 2023, which is the information that you have to look up in the table, and then also had a chest X-ray study indicating abnormality in cardiac silhouette, which is information they have to look up in the images. So you have to look up images. You have to look up information from the table side and in image side, and put them together, and then make an informed decision or informed answer. So that's what we try to do. So EHRX QA has image-related QA, table-related QA, and the multimodal QA all at the same time. So yeah, so in order to do that, we had to build one individual unimodal question answering first. So unimodal QA for table, unimodal QA for image. And thankfully for table, we already had EHR SQL, which the previous project, but the previous project was based on Mimic 3. So all we needed to do was adapt Mimic 3 to Mimic 4. So just a little bit of schema change, and that was it. So it didn't take too much time, thankfully. So we had like a good starting point. So that was done. It was this part that really took a long time, because back when we were starting this, there was a similar project called, I think it was called Mimic VQA or something from, I forgot the name of the school. Sorry about that. But there was a very similar project, but they said that they were doing it, and that they were saying that they will release it, but they never released it until very recently. So we had to build our own. So that's what we did. So starting from Mimic CXR and Chest Imaginum, we started building question answering data sets. So this is we took like only the frontal images from the Mimic CXR, and then combine that with Chest Imaginum, the knowledge graph, we can build a question answering data set. So that's what we did with, and we had like a lot of like about 377,000 question answering data sets. And if you compare it with like the previous VQAs, scale wise, it's like pretty much like very, very large. And it was the only one based on Mimic CXR when we were starting it, but after that a lot of similar works came out. So one day maybe we can merge them all together and then build a really, really strong, rigorous VQA data set for at least for the Mimic X-ray. And I'm going to talk about this so in the limitation, but just because of the for the sake of the time, I'm just going to give a very high level overview of what I was trying to do here is that because Mimic CXR, if you look at Mimic CXR, the graphs, some are kind of like uncertain. So diagnosis, when like doctors make a diagnosis, they often have like disagreeing diagnosis when they look at look at the same X-ray, and then some people might say this is malignant. Some people say this could be benign. There's like uncertainty when it comes to diagnosis. So even when we were building this data set, we were unsure if the answer was definitely like 100%. It was 100% certainty because if you look at the report, chest X-ray report, it says might be something or like indicates something or has like a hint of something, and we're trying to use that as the answer. So this is definitely, there's some uncertainty here. So we try to see how answerable our question answering data set was from this Mimic CXR VQA. So we actually did that. Yeah, a lot of technical stuff here, but basically we were trying to calibrate how answerable our question answering data set was. So turns out that it's using the most powerful multimodal model with very simple questions like yes or no questions. It wasn't always answerable. So if you look at here, like plain, like if this is like a frontal or if it's like a PA or AP, that kind of question, or is this like a female or male? Those questions are very, very like accurate. But when it comes to like size questions or the especially abnormality questions, it's very, very like underperforming compared to plain and gender. So there's like, we think that this is because there's like a lot of uncertainty embedded inside the report to begin with, and we were not careful enough, or we're not rigorous enough to like filter them out. So the inherent uncertainty kind of like is residing in this data set. So I'm going to talk about that in the limitation section. So once we have those two, the unimodal for the table, unimodal for the image, we just need to combine the two together. And basically we have different multiple types of question answering data sets, multiple types of questions, like questions that are only based on single image, questions that require you to compare two images and then see if something new happened or some disease resolved over time, or a question that requires you to look at all the images and then get like an aggregate information. Table-based questions is the same as EHRSQL, and then image plus table. This is a new thing that we're trying to incorporate. So if you have this kind of data set, then the question is, how do you solve it? Because EHRSQL was purely table-based, so you can just convert your question into SQL, run it, and then get your answer. So that was enough. But if your question requires you to look at both table and image at the same time, then SQL is not going to cut it. So we borrow this idea from a paper called Binder, which is trying to use LLM to write SQL as well as use a function call for the external like modalities. So here we have a function called function VQA, which is an external function that only looks at images. So if a question is entered into the LLM, then it should write something like this. So we call this neural SQL. So this part, the black part, is pure SQL. This part is the new thing, which is calling a VQA function to look at the image and then get the information from it, and then plug that into the SQL and then run it as a plain old SQL. So that was that's where the LLM can actually, be of a huge help, because we couldn't train this with a like T5. We could, because in order to train this, we would have to actually have a training set with this, like thousands of training samples, but we couldn't do this. But if you have an LLM, then you can just show a couple of examples as a prompt, and then you can actually make it understand and do it. So that's where like LLM's power really shine. So the performance is like purely image. So ACCLF is how accurate your neural SQL was. ACCEX is how accurate your execution result was. And you can see the big gap between the two. So when it comes to image-related question, LLM can generate very accurate logical form, the neural SQL. But when you run it, it's super inaccurate because of the uncertainty, as well as the performance of VQA function. The VQA module here has a certain upper bound. So that's where the big gap comes from. And table related, there's a question. Table related, if you can make an SQL, then you can run it. So the execution accuracy is always 100. And the image and the multimodal question, the LF accuracy, the neural SQL accuracy is like way below the 93 or 86. It's 69. So it's not really understanding the multimodal nature of the question. But with enough number of enough number of training samples, or the training samples that you can pull to make use as a prompt to the LLM, I think this will certainly go up in maybe in a few months after we like spend a few months engineering the LLM for prompt engineering. I think we can increase its performance up to maybe 80%. But then the execution result still, because of the VQA function, VQA module, it has certain upper bound. So this is EHRQA. So how EHRQA, this is a landscape of EHRQA, like way back from like 2018, 2016. And so the blue ones are the free text ones. So Meadowline, it was the recent paper from Nigam Shah's group, and Jason is, oh, where's Jason? Yeah. Oops. So Meadowline is probably the state of the art when it comes to free text-based question answering, and it has a very rigorous evaluation, employing a lot of doctrines. So we were actually reading, my students were reading this paper before I came here. Oh, Scott. Oh, your last name is Fleming. Yes. Oh, sorry about that. Okay.
I was enjoying being Scotty wouldn't find the wall here. Yeah.
Sorry about that. So yeah, big shout out to because I really enjoyed the paper. Yeah. And mimic VQA, mimic diff VQA. This is the data set that I was talking about, who are doing the similar stuff, but they didn't release it back then, but they released it now. So we need to compare how it fares against ours and see if they're compatible, we can just merge them together and then build a even more powerful VQA data sets. So this is a landscape. And there are a couple others. How much time do I have? I think I have maybe 10 more minutes.
Yeah, that would be fine. And we'll have room for questions. We total have about 20 minutes left.
Okay. So EHRXQA was the most recent one. ECGQA is also another like recent development from our lab. We wanted to build. So for those of you who are following Mimic4, they recently released ECG for Mimic4. And so we knew that was going to happen, but we wanted to build a practice run for building a QA dataset for ECG. So we did that with something called PTBXL, which I think is which is a subset of PhysioNet Challenge, I think. So it has, I think it comes from German hospitals. So we actually had to translate German report into English report, and then build a QA dataset out of that. So it's again, because of sorry for the first, but promotional purposes. First Q&A dataset for ECG signals. So based on a single ECG, you can ask questions like diagnosis, or whether there's like baseline wonder, if there's like noise, or numerical features like the QRS interval, like the peak of the peaks or arc peak, and that kind of stuff. So we try to do that, and also we try to incorporate like comparison questions as well, like compared to this guy's last ECG and this guy's current ECG, like is there any difference between the two? So very much similar structure to the EHRXQA. So like the single and comparison, and also verified questions are yes or no question. Choose are like between two options. Query question is give me all the things that is wrong with this ECG. So basically, yeah, these categories. And I'm gonna skip that. The interesting thing is so it's we have a training set. It's a proper like benchmark data set. It has training set, validations, and test set. So if you train a BERT-like model with a training set and then test it on test set, you get about 80-ish AURC overall. So M3A is kind of like one of the recent multimodal BERT-like pre-trained model. So we use that for training ECG multimodal model. And using that, you get about 80-ish AURC. But another thing you can do, another route you can take to answer these questions is to take LLM and then if you're familiar with Hugging GPT, you can have like an external ECG perceiving model. Here I wrote like ECG perceiver. So if there's an ECG perceiver that can convert ECG, raw ECG into categorical information, then you just pass the category information to LLM, like ChatGPT, and then let ChatGPT answer your question. Like let it summarize, let it paraphrase, let it answer your question. You can do whatever you want, as long as you have a structured textual information converted from raw ECG. So that's what we did. And so LLM is not fine-tuned, but prompting was used. And performance, if you see here, for certain questions, it's like it's not really out there. Like if you compare with this guy here, with this guy, I think we should compare with the execution, the execution accuracy. So if you compare with this guy, I'm sorry. This is borrowed from here. Sorry. So this and this is the same thing. They're copy paste. Compared to here, like this here, using GPT-4 with something called SERWRN. This is the ECG perceiver. ECG perceiver with 3.5 turbo, ECG perceiver with Text DaVinci 003. They're overall underperforming compared to this guy, which is actually trained for this. This is a custom model trained only for ECG QA. Compared to that, if you just combine ECG perceiver with LLM, it's not outperforming, but surprisingly, it's like kind of okay. I would say it's kind of okay. Like sooner or later, I'm pretty sure this guy will outperform, or at least comparable or outperform or for this guy. So question is, do we need to build a specific custom model for one specific purpose, like ECG QA?
On that note, I'm curious, based on what you've seen so far, do you think the bottleneck in performance here is the extraction process of going from the ECG to the structured information, plain text, or do you think it's the summary of the structured information?
I think it lies in the former.
Yeah. Okay. Can you just repeat the question, because people online can only hear through your laptop?
Oh, so the question from Scott was that the performance gap between the two. Do I think the bottleneck comes from the ECG perceiver not being not actually extracting all the information, or is it the factor coming from LLM not understanding or not being able to answer the question correctly, even if it was given all the right information? That was the question, right? So, and my answer was that probably former, because M3AE goes through a very long multimodal pre-training, like BERT-like pre-training. You mask out certain ECG segment and also mask out certain text segment, and then you try to reconstruct it. So once you do that for a very long time, it has a very strong understanding of both text and ECG at the same time. So it's bound to have a better perception ability. Compared to SEWRN here, it's basically a classification model. You feed it ECG and then you try to do a multi-label classification. It doesn't go through any pre-training, multimodal pre-training. So I think the bottleneck comes from the former. But certainly, I think the latter also plays a little bit, because GPT-4 probably is not as proficient in medical terminology as real doctors. Maybe that's also playing a little part, but I think most of it is coming from the former. Right, so that was ECGQA, and a couple other is not really specifically related to healthcare or medicine. Just gonna throw it out there because I think it's still relevant. FACT-KG is a fact verification reasoning on knowledge graph. If you're familiar with Fever, which is a fact verification data set for free text, it was done by Dr. James Thorne, who's actually now a faculty member of KAIST right now. So I actually collaborated with him to build a fact verification via reasoning on knowledge graph. So not based on text, you try to refute or support the claim based on your knowledge graph. And I was interested in this initially because there's a lot of medical knowledge graph out there. There's diagnosis hierarchy or SNOMED or UMLS. Is it correct? UMLS. So I was hoping that we could somehow use that to do a complex medical inference and then use it for fact verification or question answering. But SNOMED was unwieldy and it was too big. So I thought maybe we could try it on a smaller like general domain first and then see if it works and then move on to healthcare. So that's what we did. So we ended up using DBpedia, which is general domain knowledge graph, which is basically, it looks like this. There's like a bunch of people, bunch of places, bunch of like artifacts and whatnot. And then has all these relationships, like is a successor of, is a parent of, is a child of, and then you can build a lot of interesting knowledge graph on knowledge inference chains on top of that. So we use these 5 different chains, which is a single hop conjunction of two triples, a semi-triple, and this is the most interesting thing is it's a hop, but there's a hole in between. So if you read the text, it says Ada Stella, which is company name. Ada Stella was Ada Stella is a ship name. Was built by a company in Papenburg. So you have to go through all the companies, a shipmaker company that was in Papenburg and that built Ada Stella, and then see if there's a route. If there is a route, then your claim is supported. So I think this is the most challenging thing. And not a lot of work actually addressed this question. So we try to do it and then it works. As you can imagine, it doesn't have a good performance. And we tried to solve it in 2 different styles, again, using specific custom model only for doing this and trying to solve it with LLM. So solving KG LLM is a little bit more involved than trying to, build an ECG perceiver and then hooking up with LLM, because you need to look at the claim and then break it down to different triples and then look at all the graphs and then retrieve the relevant triples and then put them together and then build a inference chain and then see if that actually supports your claim or refutes the claim. It's way more, a little bit more involved, but maybe that's why it's underperforming compared to Gear, which is the custom model for only doing effect KG. So, but again, the gap is not that wide though. If you give like enough number of samples, gap is only like 5%. So someday, even complex KG based inference task will be dominated by LLMs. Who's gonna build, like, if you want to build Gear, like you need like a lot of training samples, and then it's very very tedious job. But if 12 shot is enough, maybe 20 shot, maybe 30 shot is enough to outperform Gear at some point. If you have a very well engineered pipeline, this is definitely not optimized. This is just very recent development from our lab, so it's definitely suboptimal. Last thing is Visalign. I'm just going to skip what we tried to do is we wanted to build the very first data set that we can promote to government officials based on, because the task is, we wanted to test if AI and humans have similar visual perception. Like when we see something, like if it's blurry or if it's dark, we actually avoid making decisions. And if it basically like this, like we have a lot of different categories. If you're looking at a zebra, then this is zebra with spurious correlation, with weird background, zebra with adversarial perturbation, something that is definitely not an animal, something that has like 2 animals combined together, like the head of an elephant and the leg of a zebra, donkey, which is a cousin of zebra, illustration of zebra, and then a cropping and blurry or noisy zebra. And we actually built constructed this data set, 100 examples per category, and then we actually, for this particular category, there is no definite answer, like if this looks like a zebra or not. Like they all have a definite answer, like does it look like a zebra? Does it look like a zebra? Does it look like we can actually know the answer, but for there is certain uncertainty here. Like, does this look like a zebra? Then maybe it's 20% zebra, 20% maybe carpet, 50% chair. Who knows what it is? Like that's this as well. Like this looks like a zebra, but if you increase the intensity of the noise, at some point it stops being a zebra and starts being something else. But as a question maker, we don't know. So we wanted to get the ground truth, and ideally we wanted to ask the entire humanity, the 8 billion people, but we can't do that. So we actually hired a bunch of MTurkers to answer the question, does it look, what does it look like, basically? So that was, we hired like 134 people for each sample here, because that was statistically, coming from statistical theory, that's how that many people are required to, estimate the ground truth with 5% error margin or something. So I actually had a statistician collaborate with me because I wanted to be able to say this data set is so rigorously constructed. If an AI passes this, then we can say that the AI's visual perception is very much aligned with humans' visual perception. So that was the whole motivation behind building this, because as I said, I think evaluation is really becoming way more important, especially with visual LLMs these days, like Lava and Lava Med and, a lot of GPT-4, GPT Vision, they all claim to have like visual perception capability. And if it has a similar visual perception as humans, we need like very, very rigorous data set. And I think this could be like one of the start, but again, the problem is in order to get the ground truth, we had to employ 134 people from diverse backgrounds, diverse country, because we wanted to do like a random sampling IID. So that becomes like very, very labor intensive. And also money plays an issue. So this was I think it was a good start, but I'm not sure how scalable it will be. When it comes to like medical data, we can't hire 134 doctors per samples to look at X-ray and then see if it makes sense. Like we can't do that. So where does the ground truth come from is my question, and also a limitation. So yeah, I'm gonna skip all this. So I think, okay, so just LLMs, I'm just gonna skip this. Everybody know, I'm trying to talk about Alpaca in Stanford, which is stupid. So I'm gonna skip that. Clinical LLM. So we wanted, after Alpaca came out, we wanted to build a clinical LLM that is only like very much well versed in clinical text such as discharge summary or nursing notes or physician notes. We try to do that. And the process is exactly the same as Alpaca, and we actually had it compete with Alpaca. And then, I mean, naturally, like Camel, which is based on Mimic3 notes and Mimic3 note based instruction following data set, performs way better than Alpaca, obviously, but it's all based on GPT 3.5. So with GPT 3, we get a bunch of instruction following examples from GPT 3.5, and then we fine tune meta, and then we get Camel. And the problem is that you can do it with very like affordable amount of money, like $700, maybe $800, just like Alpaca said. And it is available to anyone who has PhysioNet credential. The problem is that it is only available to who has PhysioNet credential, because after we like open source Camel, a lot of people reached out to us to like share the model, and we couldn't because they didn't have PhysioNet credential or didn't have any like city training or whatever. So we couldn't share our work with those who were interested. So we actually ended up building this. We call this publicly shareable because it was this model was trained on synthetic nodes. So the whole motivation was, if we trained on synthetic nodes, then there's no like privacy risk involved. We can just freely share with anyone who asks for it. So that was our motivation. So the privacy concern is gone. And also, if you can train a clinical LLM with synthetic nodes, then you don't need access to real medical nodes. So anyone who's like not affiliated with hospitals, like myself, theoretically build clinical LLMs without any privacy risk. So that was our motivation. And the way that we did it is we couldn't build synthetic nodes from scratch. So we used something called PMC patient, which is, I think it's from Tsinghua University. They actually scraped PubMed central articles and then extracted case reports, patient summaries, 167,000 of them. So we use them as seeds. So you have a case report, and then you use GPT 3.5 to build a synthetic ones. And then the synthetic ones, the way that you go from here to here is very, very much prompt engineering heavy. We actually consulted like 4 doctors to make this guy, the synthetic node, as close as possible to real nodes from Mimic3, like a lot of trial and errors. And then after that, once you have this, then you can build instruction following data set on top of this, and then fine tune your Llama or Llama 2, and then that'll become way more, well-versed in medical terminology than the general domain LLMs. So how good these synthetic clinical notes are, perplexity-wise, it's pretty much way better than PMC patient, which is not a discharge summary looking like at all. But synthetic notes, we made it look like discharge summary or clinical notes. So the perplexity is very much out there, with very much comparable to Mimic3, Mimic4. So we have that, and then this evaluation time. So Mimic3, Mimic4 based question answering data set, or like NER data set, relation extraction data, relation extraction, a lot of different like paraphrasing, summarizing, question answer. We did like 8 different tasks. And this guy, this is 7B, this is 13B. Asclepius R is the one trained on real nodes. Asclepius, this guy, the one with the diagonal line, this is the one trained on synthetic nodes, and GPT 3.5 is GPT 3.5. Compared to these three, the synthetic nodes never outperforms the real ones, but it's like, you know, like there's marginal difference. So we would say that you can build like fake, you can build like, you know, not privacy risk free model with fake nodes and then get similar performance as the one trained on real nodes. And we actually had it tested. We actually like asked 4 doctors to take a look at it. 100 samples from DISQ, which is a real question generated by actual doctors. So I think it was a comparison between these two, Asclepius and Asclepius R. So 4 doctors looked at 100 samples and then gave score for Asclepius and Asclepius R. And GPT-4, this is GPT-4, also did the evaluation, the same evaluation as doctors. And I mean, the absolute score is a little bit different, but like the relative difference is a little bit, I would say, similar. So, you know, so even when seen by actual doctors, it's not that much of a difference. There's certainly a difference, but not that much of a difference. And the decision or the evaluation result by doctors is not so much off by, or should say otherwise. GPT-4's evaluation is not so much off by 4 doctors. So that was like interesting case study. Right, so that's it. And to the limitations. So I think so 2 limitations I'm going to talk about. One is the thing that I mentioned before, the uncertain ground truth in CXR. So as it says here, often doctors do not agree on diagnosis. So if there's no GT, how can we build a test that is to evaluate AI? Because when we build a test set to evaluate someone or something, we already know the answer to, so that we can evaluate it. We can make a score. But if there is no GT, then how are we to build a test? So I don't have a good answer to this right now. So possible solution is we only ask objective information like opacity or fluid or size of body shape. Like these are like pixel information that is generally all, you know, there's like rarely any like disagreement among doctors, because if something is white, then it is white. If something is big, it is big. If something is, you know, like if a device is there, then the device is there. It's the diagnosis that usually there's disagreement among doctors, because, and also if you think about how diagnosis is made, this diagnosis is not just made on images only. It's made on, like, you look at the family history, the patient medical records, and all the other modalities, and also CXR, and then you make a diagnosis. So maybe we shouldn't force models to make a diagnosis only based on CXR. So I think that is kind of like the possible solution that I can think of as of now. And MSCXR, so there's a data set by the Microsoft Future Research Group, I think, is called MSCXR, which is a bounding box only for objective findings. So this is like a good start if you're interested in this. And another limitation, fundamental limitation into testing AI's understanding or anyone's understanding with QA is there's actually, AI, I should say AI's understanding with QA is there's a certain estimation upper bound, because testing is based on human language, and it's based, so the estimation upper bound is the most intelligent human. Like we cannot estimate whether an AI outperforms human intelligence, because test is made by humans with human language. So if AI is smarter than humans, what question can we ask? What question should we ask? And we can only ask questions to which we know the answer. So we're not, otherwise we're not, so we cannot ask something that we don't know and then try to hope that we can evaluate AI. So that's the fundamental limitation to testing AI with QA. For example, I do a lot of prediction. So do a lot of people here. 24-hour mortality prediction. We don't know the true working mechanism of how to do this. We have like idea, like, okay, like if creatinine level is this high, if the blood pressure is this low, then this patient might die with it. Like that's all we know. We don't exactly know how patient dies within 24 hours. So can we ask this question for evaluation purposes? And if AI actually seems to outperform human decision based, like for mortality prediction, then how are you going to evaluate it? So I think that's the most fundamental limitation when it comes to QA. And possible solution, I don't think there's a solution, because question is made by people with human intelligence, with human language. There's certain upper bound. possible solution is the only way to overcome it, in my estimation, is controlled experiment like RCT. So if you want to test something that is more intelligent, that is more capable than you just let it play around and see if it's helpful, see if it brings like good result, then you have to believe that it's doing a good job, because you don't have the capacity to evaluate it with your own intelligence. So just like I heard this from Marzia's, I read this from Marzia and Andrew Beam's Lancet Digital Health. I think it was false promise of XAI or something. And she makes a very good case about drug development, because she said, I think it was aspirin or some Tylenol, like we still don't know how aspirin really works, but it works because it went through like different phases of RCT, and then we believe it works, and we just blindly take it, even though we don't know how it works actually. So maybe for AI, the day will come that we blindly take it, even though we don't know how it works. We would probably never know. So that's my take on limitation. All right, thank you so much. I think I barely cut it.
There you go. We are at 1 o'clock. That was a fantastic discussion and review of many different things. We are at the hours of people need a break, and totally okay to do so. But I hope for sure you'll stick around for a few minutes so people can just approach you directly for Q&A. And let's thank our speaker one more time.
Thank you.
All right. If anybody online, if you want to drop a quick question into the chat, otherwise we'll break off and continue the discussion live.
Should I mute myself?
I'll probably close the webinar in just a second either way.
Okay.
Okay. Yeah, I'll close that out.
Thank you, great talk. I was wondering, my question is related to EHR-based question answer. So maybe train the model that actually you train the structure of the database and the relationships with the details, data, and stuff like that. How these models can be generalized to other databases, EHRs, database and EHRs, data structures completely different.
Right.
One location to another location, and so otherwise, all these models have been trained mixing, and you cannot use these models in other locations. How we can generalize these models to other healthcare systems?
I mean, that is a very, very good question. The reason that I built EHR skill with both Mimic 3 and EICU was trying to address the question. We don't have a great answer until LLM came around, actually, because with LLM you can inject certain amount of domain knowledge with prompt engineering, but it's not perfect. It's not perfect, definitely, because even if you try to explain the different schemas of Mimic 3 and EICU, I don't think there's like an automatable way to do it, unless you point LLM to the Mimic website and EICU website and read all the different descriptions of the table schemas and everything. Then it'll understand. But other than that, I don't think there's a great way for people to write maybe 1,000 token prompt or maybe 2,000 token prompt to understand the difference between the two. So there's a very relevant data set called BIRD, BIRD, which was recently accepted in Europe's 2023. It actually kind of addresses your question, where the questions require domain knowledge. Like the certain questions you cannot answer by just looking at the table or just by looking at the question. You need external knowledge, and they have a annotation for that. So that could be like a great source of, if you're interested in that kind of research question. BIRD is definitely one to check out. Yeah.
Phenomenal work.
Thank you.
I was struck by, compared to, let's say, the work you did in, 2014 to 2019, how much of this work is around building data sets, specifically, I'm curious your perspective on why the shift, and also as somebody who's trying to bring in money, do you find that trying to get funding for data set building efforts is easier or harder than sort of model development efforts? Why?
The answer to the first question is, after being in Google for a year and a half and then moving to academia, I knew that resource-wise, there's no competition in
in terms of building models.
In terms of building models, or optimizing it, engineering, it's all Google has everything, and I have nothing. So I thought maybe I should stop trying to build new models and make a breakthrough methodological like maybe let's leave it to Google engineers or Meta engineers, OpenAI engineers, and I should very much try to see if the models that they are they're like dishing out actually do what they claim to do. So, and I was after I mean I didn't think about building this data set before I looked at Mimic SQL from Virginia Tech, because I was just going to try to build a model to get the best score out of it, and then build like, okay, ours is the state of the art, whatever. But it was so easy to get the state of the art, so that's when I realized like we need a way more rigorous data set. So I think that's mainly the motivation for my shift. As for the funding thing, I don't actually say that I'm going to build data set, because the government officials I don't think they like that. They like building new things that is going to translate into tech, like the industry, and then hire. I think that's all they care about: hiring people, making money, getting taxpayers' money back to the government. I think that I don't think they care anything about papers. They never ask me about papers. Like, what kind of paper did you get? They always ask me, so are you going to start a startup? Like, are you going to hire people, or are you going to sell your technology to like companies? So I never say that I'm going to build data set, but I say that I'm going to build a very powerful LLM that can do this. And in order to say that it can do this, I need to build a data set first. So that's like part of the package. Like, yeah.
Noted.
Yeah.
Yeah, thank you for the talk. So I'm intrigued by the multimodal part of the DQ section. I noticed that you use mostly the SQL queries of things to interface with both the language model and the vision background. So I think for language model is mainly like EHR, so that makes sense. But why SQL also for like a vision background? Because like a lot of vision QA right now are doing like this kind of unified transformer. They just everything, not just the Mingo style model. Has everything. And the words and the also in the package and even the unified transformer.
Right.
Have you considered compare to that, or is because your task is mostly just like information retrieval, stuff like that?
Very good question. I also asked my question, which route should I take when I want LLMs to perceive other things than text? So should I train a multimodal LLM from scratch, like Lava or GPT-4, or should I just plug in things like Hugging GPT style? And I kind of lean towards the latter, because I want my LLM to look at EKG, X-ray, table, text all at the same time. And I'm not sure if I can train a model that can, like LLM, that can understand all those at the same time. So maybe we can build like vision LLM that understands vision. Maybe we can build like audio LLM that can understand audio. But can we build an LLM that can understand EKG, images, text, time series, like all those different modalities at the same time? Like, how are you going? Maybe OpenAI can do it. They have the resources, but I definitely can. So I'd rather go to the other route, where I just have a specified perceiver for each modality that extracts categorical information, and then just feed that to a very powerful LLM. They can just do whatever it wants with the categorical information. So that's my take.
Yeah, so new idea, then this kind of intersection with different foundation models that will be SQL. And do you think that's a promising direction to pursue, or do you think there's other things in the horizon for the next?
So the reason that I kind of use SQL is because I'm using table data as like a ground, or like a headquarter. So there's EHR, which is a very, very large table data set. And then there's like X-ray, there's EKG, there's like text that are kind of like the branching off information from EHR. So I'm using SQL because I think EHR is like in the center, but it doesn't have to be that way. You don't have to use SQL to extract or retrieve information from table. There are other ways. It's just that SQL is the fastest and is most reliable. So I think, does that answer your question? Okay.
Well, related to that, I'm curious, sort of, do you find that there are certain outputs from the perceiver modules that are more beneficial for LLMs? Like it feels like you have this disjoint optimization process now, right? And maybe that the kind of structured information that you or I would want from a perceiver may actually not be optimal for the kind of information that an LLM needs as input when it's doing quick answers. Have you found there to be any sort of like surprises along that route where if you try and optimize, like if you try and optimize in a particular direction that didn't seem intuitive on the perceiver side, actually ended up giving you better performance?
Oh, actually, that's a very, very good question. I haven't thought about that because the way that we trained perceiver was, it was designed to answer questions from the ECG QA or EHRs QA. So
Right.
it wasn't a general perceiver. Like general, if I'm to build a general purpose perceiver, then there might be a gap between what perceiver outputs and LLM expects. But the way that I trained perceiver was very much like mission specific. So there wasn't a gap between the two. But as you said, if you want to build a like general purpose perceiver, then there definitely could be gaps between what it outputs. Yeah.
Like you take the instruction, pass it to the perceiver.
Well, the perceiver doesn't have an instruction. It's just a classification model.
Yeah. Okay.
Yeah. You just put X-ray and then it multi-label. Yeah, multi-label. Yeah.
Thank you for the talk. Really enjoyed it. I'm kind of curious. Did you find like it easier to get access to like medical data in like South Korea as opposed to here? Are the regulations the same?
Oh, it's way easier here than in Korea, because I talked about this at last night dinner with Nigam. So, United States has HIPAA. So as long as hospitals follow HIPAA, then they're like covered from all the like repercussions, legal repercussions. But Korea doesn't have HIPAA, so it's all on hospital responsibility. Like it's on their ass if something goes wrong. If they decide to release the data after a certain amount of de-identification, something goes wrong, then it's on their ass. So they don't want to do it. So that's reason one. Reason two is like they don't, even if there was like Korean version HIPAA, they don't have the motivation for it. Like there's no like interest or drive for them to release their data like Mimic3 or EICU, because what is there to gain for them from releasing their data? Is kind of like releasing their weakness. Like, oh, we have this amount of people die in our hospital, we have this amount of misprescription. Like you can like dive in, you can dissect the data and then see all the kind of things that are going wrong in the hospital, and who would want to do that?
I feel like that's more like, I don't know, like a academic cultural thing. Like it's like, oh
no, it's business thing. Like if I was a hospital director, I would never release the data. Like even if because I'm an AI engineer who has dire need for data, but even if I was a hospital director, I wouldn't do that for the sake of hospital business operation. And a lot of people ask, like, why aren't they releasing data or like more willing to share data with AI researchers to build like clinical LLMs and all that? Because it's all the hype. Like they can do like great stuff with LLMs, even if only if they're willing to share the data. And my answer is that they just need to wait 3 years or 5 years before they have everything on their hands. Like AI grad students are pouring out of grad school, like thousands of them every year. Hardware is getting cheaper, so they can just wait for like 5 years and then just hire mediocre okay engineers and then buy 800 chips and then start building LLMs for me. And then they'll be able to, because like technology is cheap. It's the data that's expensive.
That's interesting. And would the benefit of that be like the data is local, so it's like secure? It's like you don't, I guess, leak it in any way.
They make sure this never leaked.
Right.
Yeah.
Okay.
Yeah.
Also, follow up to that.
Yeah.
Are there like industry players you're really interested in or you're intrigued by?
I think like Google and Microsoft, they're both moving very fast in the healthcare space. I think Google has something going on with Mayo Clinic. Microsoft has something going on with Epic, I think. So I pay attention. I read the news, but I don't pay like too much attention because now it's all business and there's very little I can affect. Like way back in 2014-15, like if I wrote a paper on prediction model, there some healthcare companies would reach out to me actually and then ask me questions like, we want to implement your model and there's something like there's a hiccup, like how do you do it? Like I got called from like United Healthcare or Optum, like actual real. This never happens after like 2018 or 2019. It's now, I think it's the capital that drives AI, not individual researchers. Sadly, it's like I don't want to put you guys down too much,
No,
but
of course. You feel like what would be the way to align that incentive, do you think? And make it easier for researchers with help like from industry.
that's a very hard question.
It's unanswered basically.
Yeah. Scott, do you have an answer?
No. I'm enjoying the ride. Yeah.
So there are two sides.
Yeah.
The professors who say that we should tightly connect with industry and then like, not exploit, but use their resources, whatnot, and then have a close relationship and then co-author, co-publish. That's one ride. And I'm on the other side, like we should just go our separate ways.
I think talking to like person A and HAI, for example, and amongst the students as well, it was an interesting conversation with like a bunch of NLP students who are trying to figure out what the heck can we do now. Where like pretty much all of our model building objective has been eaten up by tech companies. And I think what we came to as a group was switch your objective. Focus on things that either aren't profitable for large tech companies,
Exactly,
and or are like so legally or ethically risky in the sense of it's like something important to do, but it's such a low priority or has such high risk for the business objective.
I would 100% agree. I had a similar question when I was in like Switzerland. Companies can only spend their money that is profitable for their business, so they won't do anything. That probably the reason why healthcare is really never took off in IT space, because it's not profitable directly within like 2 years or 5-year window. So I would definitely agree with Scott. Yeah, but that's coming from like a pure researcher. If you are more of an engineer rather than a researcher, like if you're like there are two like people have like different characteristics. Some people are very academic. Some people are more like engineer, like money making business, like that side of thing. Those people should definitely do like internship very often. Just stay close to what's happening in the industry, and then eventually you're going to want to work in Google or Meta or OpenAI. So having close connection would definitely help. Like, yeah, I would encourage that. But if you are a type of person who is like purely academic, very research oriented, very like you don't think about industry at all, you just want to be like a faculty member at some point, then like finding a very worthwhile problem that's going to last long term enough so that industry is not going to take away your problem. Finding that problem is very important.
Well, I think work you're doing on data set construction, for example, and principal evaluation is very clean in that space, right? Like I was never going to build a mimic.
Yeah. They're never going to do that.
Yeah. But it's important for the work you're doing, both on model development and evaluation. Yeah,
I mean, the problem is that I'm too dependent on mimic because I don't have my own data. So I'm kind of doing like very good work for Beth Israel Hospital for free with Korean taxpayers' money. Like they wouldn't like me. Like Korean government really probably doesn't like. I mean, if I tell them exactly what I'm doing, they wouldn't like it. Yeah. But yeah, the data access is very, very, very difficult in Korea.
Thank you so much.
Yeah. I think Dr. Chen just left. Is he coming back?
I don't know. I think he's not.
Okay, so maybe we can just wrap up if there's no more. Any question? No? All right, thank you very much. Yeah. But regarding what?
So you said that if I can work with snowman, that it might be large for some purpose.
Yeah.
Wondering what's the size of it?
I forgot the exact number. There's like billion, trillion like nodes in there. And the problem is that a lot of there's like different relation, but most of them are like is a relation. Like this is all that, this is all that. And it's not very interesting to make a like claim, like a fact verification data set or fact verification questions based on is a relation. So I ended up not using it for now, but maybe sometime later. Yeah.
So what kind of relation would be really valuable?
Like cause and effect. Or there is certainly like cause and effect relationship in SNOMED, but I don't think it's comprehensive or rigorous enough yet to build something that is like rigorous data set out of it. Yeah. And this is coming from like a couple of years ago because I haven't dealt with SOMED very recently, but it's very noisy, and I think I'm not sure how it was constructed, but it seems like it was like semi-automatically constructed somehow because it's very noisy, very duplicate information, and probably there's like cycles somewhere. So
Oh yeah,
okay, I see.
What
Oh, I see. Okay, maybe you can maybe you can build it. Okay, someone. Right. I don't think there's any question from the internet, from the web. So
Do you know how to get to where you're going next?
what?
Do you know how to get to where you're going next?
I have a meeting with Dr. Olivier Gevard
Oh,
in 2 p.m. But until then, what time is it now? Okay, I have like 30-minute break. Okay.
what is a little coffee shop anyway too?
Sounds good. All right. Thank you, Gil. Thank you guys. Bye-bye.